So now we are here to do the same practice as we done in the last lecture 4 part 1 in simple linear regression model. Now we will be doing the same practice for this multiple linear regression model, and now I am just adding one more explanatory factor x2. If you remember that we have done all this calculation in the last video, where we have one dependent variable and one independent variable, but now I am doing the same practice with the second of explanatory factor. So for that second factor, if you remember that I have taken a dependent variable as total expenditure and independent vector as income. So now I'm taking another independent factor, that is food expenditures. So I will be just copying it from this sheet and taking it to the multiple regression with the second variable. So this is x2, which is the second factor, which is the food expenditure ratio to the total expenditure ratio. So that's actually, if you remember that we have done it with the unit ratio of 1000, and we have done it the unit ratio of this income as well as 1000. Sorry. Yes, it is. I'm just taking it again, copying it, and sorry, it is showing it in the subscript. I would change it to the normal, going to the format cell and just unchecking the subscript. Okay, so this is again in 1000, and that is actually the total expenditure to food expenditure into total expenditure. So that would be in ratio form. Okay. So right now I'm just giving you the unit measure as the food expenditure to total expenditure. So that is actually in ratio form. So here again we are having for total expenditure as a function of income and food expenditure ratio. So now we are having one dependent variable and the two explanatory factor x1 and x2. We will be discussing the scale of the variables and the use of these scale into the interpretation later on. But right now we are interested to just have one dependent variable and the two independent variable, as we have seeing in this spreadsheet. So now for estimating again the multiple regression model, we are having two ways of one is equation method, another is formula method. I have taken here equation method firstly, and then we will go for the formula method. And if you remember that our multiple regression model was something like this: y is equal to b0 plus b1x plus b1x1 plus b2x2 plus u, and the estimated form of this function was y cap is equal to b0 cap plus b1 cap x1 plus b2 cap x2. And for this estimated form we need to have we need to estimate the b1 cap, b0 cap and b2 cap, and for that calculation we are having two processes. One was equation method, another was formula method. So first of all I would like to expand or to estimate this calculation by equation method. And you know that in the lecture 4 we have done these normal equation from this abnormal system. So we are having three equations, and these three equations have come out from the ordinary least square process. So that's why any estimates we are doing from this process would be called OLS estimator. So in these three equation we are needing the certain sum of variables, sum of products, and sum of squares, and that is being written in the equation form as well, and that has been taken as separately as well, just to get the proper calculation from the this data sheet. So right now I am just taking the necessary calculation, where we are needing x1 square, where we are needing x2 square, we are needing x1 into y, we are needing x2 into y, x1 into x2. Here is written as y square factor, but in this stage this y square is not needed, so that's why I will be calculating just only these 5 factors. And obviously we are having a number of observation, that is 15, 19. That would be 15 and 19 are number of sample size. So x1 square, we will be multiplying x1 with the x1, so that is x1 raised to power 2, that is the square of the x1. This is the square of the x2, that would be x2 and with the raised to power 2, and this would be x1 multiplied by y, so that is x1 multiplied by y factor, and this is x2 multiplied by y, that would be x2 multiplied by y factor, and that is x1 and x2, the product of x1 and x2, so that is this is x1 multiplied by x2. And so for these 5 factors are being estimated, and now just I'll be double clicking it to have a complete calculation of these sums and products. So I'm just holding it corner and double clicking it to get the all calculation done. Oh, sorry, why it is doing over only there. Okay, I think there is somewhat okay, I'll be taking it right down like that, 1500 and 19, that is somewhat calculation. Okay. So we have done successfully the taking of squares and the product form, and now I'll be taking the sum of it. So just again using this auto sum function, I'll be taking the sum of all required estimation. And how it is being done, just I'm clicking on the auto sum, and it is now asking me what kind of sum we are needing. So here I'm clicking on the first cell of y and shift and arrow down, and with the enter I'll be having the sum of y, and with the same process I'll be adding all these cells as well. So here we got all the required sum of the squares and sum of the product, and later on we will be needing the mean of the 3 variables. I'm taking again using this average function, and from this average function I'm taking the average of this y column, and by clicking it I'll be getting the mean of y, and similarly I'll be taking the mean of x1 and x2 with the similar practice. Here we got the mean of x1 mean of x1 and mean of x2. Now we have the required calculation for the equation method. I'm getting the larger picture to explain it clear to you. So this is our basic equations, and we know that this system of equation is normal system, and we can solve this system of equation to calculate the value of b0, b1 and b2 by any method of equation that can be what we can say that can be from elimination method, from substitution method, or any process of the matrices. Here I'll be solving this system of equation through matrices method, matrix inversion method actually. So I'm just taking this system of equation, transforming into the matrix form. So this right hand side of the equation is being transformed into matrix form like that, with this product of these two matrix and the left hand side of this matrix has been taken as the constant on the right hand side. And I've told you that if you know the process of transforming this equation system into the matrix form, you need to have some kind of a beginner tutorial for the matrices. And after that transformation of this system of equation to the matrix form, this main matrix I've taken as A, and that required matrix to be estimated as taken as X, and the left hand side the constant matrix has been taken as B. And if we shift or if we take this A vector into the right hand side, that vector change into the inverse form. That makes sense to have the value of X by multiplying this A inverse with the B. Now we have just need to get the inverse matrix of A, that would be multiplied by the B. So for that I've just taken the values from this matrix into this form, into these 3 by 3 column and 3 by 3 matrix with 3 rows and 3 columns, and all these values can be taken from these sums, as you know that we have taken the calculation required. So I'm taking this matrix, all these matrices in the calculated form in from here. So first column would be the n column, so that's why I'll be taking first column equal to n, that would be n. Then that would be summation of x, so summation of x is this, that is summation of x2. Summation of x2 is equal to this one, and again summation of x, that is summation of x again. This is summation of x square, this is summation of x1 square, sorry, that is 1 square, and this is summation of x1 into x2, that would be summation of x1 and x2 is like that. And summation of here we need summation of x2, summation of x2 is this, summation of x1 and x2, summation of x1 and x2 I'm taking from here, and finally summation of x2 square, so that summation of x2 square would be taken from here. And the constant column I'll be taking again from the same calculation. Summation of xy I'm needing, I'm taking summation of xy from here, summation of x1y equal to summation of x1 y is taken from here, and summation of x2y, that would be taken from that cell. So this is all the required calculation I've taken from the summed cells. So now I would be having the inverse of this matrix, and you know the process of inverse of this matrix I have told you in the last slides, in the last lecture, in last video. I'm doing it again here. You need to just have to select the same area for the inverse matrix. So I'm just taking 3 by 3 area for this inverse matrix, and just going for the function of M inverse. So this is M inverse, double clicking it, it is requiring requiring from us which area or which matrix should be taken for inverse. I'm just giving the required area, and now not hitting the enter directly, I'm just I'm hitting the control shift enter. So control shift enter if I took, then I got the required inverse matrix. So that required inverse matrix which is equal to a raised to power minus 1, if this is multiplied by this B matrix, I'll be getting the required required answer of the matrix. So required answer is I'm highlighting the area from this. It is the process of the multiplying the two matrices. First of all, highlight the required area. You know how the resultant matrix order, because if I am multiplying this 3 by 3 matrix from multiplying it from 3 by 1, so I'll be getting in resultant 3 by 1 matrix as answer. So I have highlighted the 3 by 1 matrix area, and now I will be going for the function of m multiply mm, that is m multiply. I'm just clicking it on, and now it is requiring that which two matrices are being multiplied. I'm just showing it the whole area of the m inverse with the comma and along with this second matrix, and again I'll be hitting Control Shift and enter. So this is actually the values of B0 cap, B1 cap and B2 cap. So that's how we can calculate the values of these estimates through these equations. Similar now I'll be doing the similar calculation from a formula method. Now here you can see the formula method. I am having three formulas for B0, B1 cap, B2 cap and B0 cap, and for that the requiring estimation is now here, because and now it is not the level form of variable, because you can see that in the formulas we are using the small alphabets. It means that we are using the deviated form of the variable. Now it is not capital X1 square, it is small x1 square. So that's so for this we need to have deviation form of all these variables. So we should do the required necessary calculation. So for the multiple linear regression model and for the deviation process, where we are having two formula of the deviation, three formula of the deviation method for B1 cap, for B2 cap and for B0 cap, and for that we would be needing the sum of squares of deviations and sum of squares of the product. So first of all we have to take the deviation of the variable, because no level of variable is being used over there. So for that I'll be I'll develop this some columns for the deviated values, and you can see that here we have small y rather than capital Y. Here we have a small x1, a small x2, and you know what these small alphabets stands for. Small y is the deviation of the actual or plain y. It means that the mean of y is being subtracted from the each value of original variable. So similarly x1, small x1 bar, small x1 is actually the deviation of capital X1, and small x2 is the deviation of capital X2. So for that, if I take the deviation process, so that would be subtracting the mean from this original value. So I am clicking here the original value minus the mean of it, that is the mean of y, and that would be a log for the whole series. Similarly, x1 bar, small x1 bar is the deviation of capital X1, so that is capital X1 value minus the mean of x1 bar should be subtracted from this, that is mean of x1 bar, and log the value for the whole series. And again x2, small x2 bar is the deviation of capital deviation of x2 values from the x mean. So that are the x2 value, and subtracted the mean of x2. Here is the mean of x2, and again I'm locking it for the whole series. So there we get the small calculations, or sorry, the small alphabet or the deviated values calculation. And now I'll be having the sum of squares and deviations. So because no level values is being used as sum in the formula, we see that the all sum of some values are either for the square of the variable or the product of the variables. So for that I would go for the sum of a square of x1, small x1. So that is a small x1. So here I am taking the power of 2 again, and here it is the square of x2. So that is x2 with the power of 2. This is the product of x1y, that is product of x1 into y, and that is product of x2y. This is x2 multiplied by y, and that is x1 and x2 product. So that is x1 multiplied by x2 product. So all this calculation have been done, and now I'm just double clicking it to get the whole series in calculation. So this is whole series calculation, and we got the sum like these values, because I've put up the formula already. So we got the sum of x1 square, sum of x2 square, sum of x1y, sum of x2y, and sum of x1 and x2. Now just to put all these values into these formulas, and we will get the values of the factors. So here I am putting the values of B1 estimator, where again in the numerator I am having 2 factors subtracted. These are the 2 factors subtracted, and divided by again 2 factors subtracted, like that. So if I go for the formula, it will be like that, and from the first factor of numerator is x1y into x2. So that is x1y multiplied by x2 square, and in the second factor of the numerator, it is x2y into x1 and x2. So that is sum of x2y. This is sum of x2y multiplied by x1 and x2 product. And in the numerator, summation of x1 square multiplied by summation of x2 square. So that is summation of x1 square multiplied by summation of x2 square. And in the last, sum of x1 x2 whole square. So sum of x1 x2 is this, and with the power of 2. So you can see that the B1 is calculated 0.25182, which is as calculated earlier as there. You can see B1 is calculated here from the matrices method. It is as same as B1 here estimated from the formula method. Similarly, here I'll be following the formula for the B2 cap, and again I'm putting some parentheses over there. That is a numerator. Two factors are subtracted. 2 factors are subtracted, divided by the numerator, and again 2 factors are subtracted, and again I'm just putting the values. So here summation x2y is this, multiplied by summation x1 square is this, and minus summation x1y, that is summation x1y multiplied by summation x1 and summation x2, divided by summation x1 square, this is summation x1 square multiplied by summation x2 square and minus summation x1 and x2 whole square. So that is making whole square of it. Sorry, I have done something wrong somewhere. Where I have to look in detail where we have done mistake. That is summation x2y, that is summation x2y, which is this one, and multiplied by summation x1 square v37, that is summation x1 square, and minus summation x1y, that is summation x1y, that is v39, that is v39 x1y, and summation x1 and x2, that is summation x1 and x2, and divided by summation x1 square, that is summation x1 square, which is this one. This is summation x2 square, which is this one, and minus summation x1 and x2 whole square. Sorry, I have forgotten the power of the function. That is okay. So that is b2, which is which calculated minus 162.37, which is same equal as we done in matrices method. And finally b naught cap. Here we will be following the formula where the b naught cap is like this one. So it is very simple. I'm just putting the formula over here. That is y mean of y. Mean of y is this minus b1 cap. B1 cap is there. This is the b1 cap multiplied by x1 bar. X1 bar is this. Then again minus b2 cap. B2 cap is this, and multiplied by x2 bar, which is this. So by having we have again made some mistake. We will see what kind of mistake we have done. So that is y bar, this is y bar, that should be y bar minus, okay, I've not used parentheses. So if I use parentheses over there, let's see if it makes some difference. So it should be no, this is not the case of parentheses. There is something else. Let me check it in detail. I think here I have just put the wrong value, that is x1 bar. It should be x2 bar actually. Yes. So this is 122.26 122.2676 is the parameter estimate for the intercept. So guys, here we have calculated the the values of multiple linear regression through formula method and as well as through matrices. This is from matrices method, this is from formula method, and we see that we have the same values from the both methods. So guys, this is the techniques to calculate parameter of ordinary least square from manually from formula, from equations, using Excel as a calculator. Otherwise we have no need to do all these things if we are doing somewhat kind of research methods or research techniques, because softwares like Excel and other softwares facilitate us to avoid all such manual practice. They can calculate these three parameters and other material as well with one click. But for the sake of having you the idea behind the parameters and the calculation of the parameter, so this seems to be necessary for the beginners who are learning estimation of econometric model. Either it is a linear function for simple model, or it is a linear function for multiple model. For this, so that's why it is better for the beginners. Thank you very much.